We're looking at sections 5.8 here and 5.9. We'll see how far we get here, starting with 5.8. We have variation. So that means we have two variables, and we have to see how one affects the other. Do they both go together, go up at the same time? Do they both go down at the same time? Are they in opposite directions? Well, the first one we'll take a look at is direct variation. What direct variation means when you have an equation where we have y equals mx plus b or y equals kx. As x goes up, so does y. It could also be written as an exponent as well. So you could have y equals x to the m. So this k is a constant, okay? It's a number that stands for any number that we want to put in there. It's a constant. We usually solve for it. So they're asking for what the graph appears for a direct variation. What does a graph appear like? Well, it could be as simple as a straight line going this way. As one variable increases, so does the other. Like as the amount of rain increases, the amount of plant growth increases. Think about two things that go up together or down together. So the graph might look something like this or something like this, where as you move to the right, you also move up. As you move this way, you also move this way. That's direct variation, and that's what the equation looks like. All right, that's what the equation looks like. That's what the graph looks like for direct variation, where one variable increases and so does the other one. Now, two variables vary inversely. It looks like when you put, so again, we insert this k just as a constant, a number we solve for. We put it in the equation. It's where x is in the denominator. So when x and y are on opposite sides of the equation, it's going to be inverse relationship. K is in the numerator and x is in the denominator. So it could be y equals k over x or y equals k over x to the n. And as you can imagine, the graph's going to look something like this. As one variable increases, the other variable decreases. So it can be something like that. So where you have one variable is going in one direction while the other variable is going the other. Okay, so opposite. So now we get into equations where they say they want an equation where y is varying directly with x, and x equals 2 and y equals 10, and then they want to use that information to find y if x equals 4. So what that really means is that you have to solve the following equation first, get the k, and then put the k over here. So what we're going to do is we're going to write down y equals kx, because remember in the beginning we said direct variation. We have like a linear expression like this, y equals kx or kx to the n. So therefore, we solve this equation using the x and y that they gave us. So we're going to get 10 is equal to k times 2. So k is equal to 5. And then so now we really have the equation of y is equal to 5 times x. So if they tell us that x equals 4, we're going to get y is equal to 5 times 4, which is equal to 20. So therefore, y is equal to 20. And that's all they're asking us to do there. Number 4, they tell us that y varies directly with x, and they give us an x and a y, and they want to know what y is. So when they're saying we don't know what y is, they're asking for an equation. So they're looking for an equation that says y equals kx. Okay? They didn't give us another value for x like they did here. All right, so this means they're just looking for an equation. So therefore, you start with y equals kx because it says it's direct. You put in your values here, and you get 36 is equal to k times 2. So therefore, k is equal to 18. And they don't want you to solve the second equation. They just want you to write down the equation y equals 18k. Oh, excuse me, not k. Y equals 18x. K is the 18. That's y equals 18x. That's what they want there. Now let's say you have a weekly allowance that varies directly with grade. So like the older you are, the more money you make. So a 9th grader makes $9.66 a week. What does an 8th grader make? So in that particular case, you would say y is equal to kx, because it varies directly. And we're going to say that y was $9.66, how much you make, is equal to k times 9. So then we solve for k, and we get k is equal to, and it's going to be 1.073. So you get k is equal to 1.073. That's what k is, and then we use that to find how much allowance an 8th grader would make. So that's the y value. How much allowance is equal to k times x. Well, in this case, x is 8 for 8th grade. And the k is going to equal to, as we know, 1.073 repeating. So we multiply that out, and we get y is equal to 859 if you round it to the nearest cent. All right. So you write down y equals kx, you put in the values that you know, solve for the values that you don't know, which in this case is k. Then you reuse k over here, multiply times the 8 for 8th grade to find out how much the 8th grade allowance will be, which is represented by y. And that gets 859. Now, the time is inversely related to people working on a job. So 5 hours, it takes 5 hours for 7 workers, bricklayers, to build a well. How many hours would it take for 17 bricklayers to do the job? So you have time is inversely proportional. That means we put the k in the top and the bricklayers in the bottom. All right. So in this case, we had time. So we have 5 is equal to, it took 5 hours for over 7 bricklayers, right? We put our values in. We know 5 is the time. We know 7 is the bricklayers. We put that in there, and then we do cross products, and we get k equals 35. And then we use that 35 to solve the second part of the problem, which says how much time. So time equals k over b, and k is 35. So we have time is equal to 35 over b, which in this case is 17. So it's just going to be a little over 2 hours. So time is going to equal 2.1 hours. So it's going to take 2.1 hours for 17 bricklayers to do the same job. Well, that makes sense because that's more than twice the number of workers, and it takes a little bit more than twice the time in order to be able to do it with less workers. So that makes sense. They tell us that P is inversely proportional to Q, and they give us a P value and a Q value, and they want P equals, so that means they want an equation that says inverse. So therefore, you're going to have P is equal to K over Q. Q is in the denominator because it's inverse. We plug in our values. We're going to get 12 is equal to K over 5. So we get K is equal to 60. And then we replace that value into the original equation, which is what they want. They want P equals K over Q. So we're going to get P is equal to 60 over Q. And that's all they want for that one. For number 7. For number 8, they want a function, h equals. That's what they're looking for, h equals. And they tell you that h varies directly with d squared, which I think is distance squared. So therefore we have h is equal to k d squared. So we just have to solve for k and then put our answer. So we know that h is equal to k d squared. We just need to solve for k and put that in there. Okay, so it's going to be h equals box d squared. So we replace our values. We're going to get 63 is equal to k times 9. So k is going to equal 7. So therefore we can replace this formula and we get h is equal to 7d squared. 7d squared. Okay, that's the equation. They wanted a function, so a function there. So they want a function a equals, and they tell you that the so I guess area varies inversely with the square root of the radius. So therefore, we know it's going to be a is equal to k over the square root of r. All right. So we use the values that we have. We say 5 is equal to k over the square root of 25. Well, we knew that already. Okay. So we have 5 is equal to k over 5. Sorry about that. So we're going to have a is equal to k. A is equal to k over root r. So we have k is equal to, now this was 5 and this was root 25, so k is equal to 5 times 5, so k equals 25. So then we use 25 and we write I think they want a function, so it's simply going to be a is equal to 25 over root r. So what we're doing here is we're just replacing this with 25. That's all we're doing. So that's the equation that we want. They tell us that z varies directly with y and directly with x cubed. They also say jointly is another way to say that varies directly with two different variables. So this is a numerical problem that we need to solve. So we're going to say z actually. Z varies directly with equals k x z. So we'll write that out there. Z is equal to k cubed y, and then we put in our values and we get z. There's 4320 is equal to, and then you have k, which we're trying to solve for, k, and then 216 times y, which is 10. So you're going to get 4320 is equal to 2,160k, and then divide by k, divide by k, divide by k, and I think we should get k equals 2. And once we have 2, what do they want? They want us to figure out this problem. So we have z is equal to k x cubed y, and they want the z value. So they want z is equal to 2 times, again, x cubed is going to be 100. 10 times 10 is 100 times 100,000. 10 times 10 times 100,000 times y, which is 1. So z is going to equal to 2,000. There we go. Now this one says z varies jointly with x and y. So if z varies jointly with x and y, it's going to be z equals k times xy. Alright, so they want to know what z equals first. Alright, so that means that we have to solve for k and using these numbers and work backwards and then put that in there. That's what we need to do. So therefore, we're going to get z, which is 261 equals k times xy, which is 10 times 3. So we're going to get 261 is equal to 30k. So k is equal to 261 over 30. So k is equal to 8.7. So therefore our equation is c equals 8.7 xy. So that's our equation right there. It's our formula, but then they want to use that k to solve for z using these numbers. So you rewrite the formula with your new z. Z is equal to 8.7 xy, and then you put in your x and your y. So z can equal to 8.7 times 5 times 15, and you get z equals 652.5. So that was a two-part question. One was just to solve for z, writing out the formula correctly, and then the second part was to use that formula to be able to find a new z given a new x and y value. They tell us that time varies inversely with speed, and that makes sense. So time varies inversely with speed. So you can have time is equal to k over speed, and then we use this information to find out what k is. So time was 4 hours. 4 is equal to k over 100. So you do your cross products and you find that k is equal to 400. So once you have that k is equal to 400, we'll plug that back in. We find out how many hours will take. How many hours will take if we do the same trip at 8 kilometers per hour, a lot less than 100 kilometers per hour. So you're going to have what the time is equal to what? K, 400. So we're just using this formula again, plugging that in over s, but now is 8. So we're going to have the time is equal to 50 hours. So since you're going a lot slower here, you're going to take a lot long time to get here. Okay, here they tell us that I varies indirectly with d squared. So indirectly means inversely. So you're going to have I is equal to k over d squared. You plug in the values that they gave you, and you're going to get 21 is equal to k over, and that's 4.5 squared, which is 20.25. You do cross products and you get k is equal to 425.25. And then you take that and you use the formula again. I is equal to, you put k back in, 425.25 over, and then d squared with a new d right here, 0.75 squared. And that's equal to 0.5625. You divide that out, and you get a bigger number of 756. So I will equal 756. Horsepower varies directly, jointly with the speed. That means k s d cubed. You put in the values that they give you, and you get 400 is equal to k 125, and then times, what's that, 664 s cubed. So you do that, and you're going to get k is equal to 400 over 1600, so k equals 1/4. You put that back in using these numbers right here, and you're going to get 101.25 equals 1/4 times 75 times d cubed. You do that, and you're going to get 405 over 75 equals d cubed, and you get d is equal to the cube root of 405 over 75. Therefore, d is equal to 1.7544 inches. So the disc diameter goes down if you're going slower. I'm not going to have time to fully do, but I'm just going to tell you that it varies directly as the square of x and the cube of z and inversely as the square root of w. We're going to tackle this problem in the beginning of the next video.